Yo, 2022 AS Physics Unit 1. Last question of this paper is our stars question and radiation. Part A, explain what is meant by the term black body, learn it off by heart. It's something that absorbs all the radiation that falls upon it, and of course stars are very good models of a black body. Part B, nothing really to do with physics, this was a bit of mathematics. The graph shows intensity in kilowatts per meter squared and how that varies from the sun's distance. And we've learned in class this is an inverse square law. And the question says to confirm that it shows an inverse square relationship between I and D. Now you've got to cast your mind back here now to year 11 maths, where we did proportionality. And if y was proportional to x, we would have put y equals kx. And if y was inversely proportional to x, we would have put y equals k over x. Well, here we've got to show I is inversely proportional to d. So I is proportional to 1 over d squared. Sorry, the square. So I equals k over d squared. Right, so I've brought that d squared over as a times. I didn't have to. And I've set up a table of values. So when I is 3, D is 1. When I is 3, D is 1. 3 times 1 squared gives 3. So my constant of proportion there is 3. And let's pick another value. When I is 2, D is 1.25. Do 2 times 1.25, I times d squared, and that comes out as just a little bit over 3. Pick another set of values. When I is 1, d is 1.8. 1 times 1.8 squared comes out as 3.2. Pick the last set of values. I went all the way down for I is 0.2. That marries up with d being 4. 0.2 times 4 squared. And that comes out as 3.2. So for all of those examples of corresponding values of I and D, I've shown that the constant of proportionality for all of them is approximately 3, and that's close enough to say it's an inverse square relationship. Right, on to the physicsy stuff. Show that the sun's luminosity is approximately 4 times 10 to the 26 watts. They've given us the answer. That's a good thing. So the intensity of the radiation coming from the sun is its luminosity, its power, divided by that inverse square law, 4 pi r squared. We've learned this in class, where r is the distance between the two objects, or the distance away from the sun in this case. So I've just brought the 4 pi r squared up because I can get the value of the intensity from the graph. I can get the value of the distance r again from the graph. So I can pick any of these pairs of values here that I've got from the graph. I've chose to pick the top one because it's the easiest. 3 times 10 to the 3, don't forget. It's kilowatts. And then 1 times 10 to the 11, don't forget to add on the 10 to the 11 in the units part of the graph. Squared, chuck on in the calculator. Calculator says 3.8 times 10 to the 26, right? That's close enough to being 4. Cover the page. Here's a spectral intensity graph, and in a nutshell, they asked us to calculate the radius of the sun. So you know on your stars question, you're going to have to use Wien's law, you're going to have to use Stefan's law, and you'll get that from getting lambda max on the spectral intensity graph, right? So the maximum wavelength is 500, don't forget that's nanometers, 10 to the minus 9. So chuck that into Wien's law, allows me to get the temperature, which is 5,800 K, which you should know is about right for the sun. Then we'll go into Stefan's law. The luminosity, which we just worked out, 3.8 times 10 to the 26, is sigma, Stefan's constant, 4 pi r squared, the radius of the sun, times t to the 4. All right, so we're going to have to do a bit of rearranging. We know this, we know this, we know this, we know this, and we know this. So I'm going to take them all over to leave me with r squared. So all of these 4 things would go over and underneath. That would leave me with r squared. I then need to square root that to get the radius of the sun. Put all the numbers in, press the buttons, excuse me, and it comes out to 6.9 times 10 to the 8 meters. Be careful, sometimes they will ask for the diameter. Don't forget to double it at the end if they do ask for the diameter. Sometimes they give you the diameter and they ask you to work out the temperature, etc. Don't forget it's radius that is involved here, because this is effectively the area, isn't it? The surface area. And, luminosity is sigma area times t to the 4, and the area of a sphere is 4 pi r squared. Pretty decent stars question. I even put a smiley face. Happy days.